Hello everybody, welcome to question 21 to 30 of Mrs. Baker's Monster Papers, paper 2, and it's module 12. So helium is a noble gas. Which statement about helium is correct? It has 8 electrons in its outer shell. Ooh, sneaky. Helium is actually in period 2. It's the only one with 2 electrons to give it a full outer shell. So, Diatomic? No, it's monatomic. Is it reactive? No, it's very unreactive. Is it used for filling balloons? Yes, because it is very, very light. It's much less dense than air. 22, part of the periodic table is shown. Which element is used to provide an inert atmosphere? Of course, inert means noble gas. No-brainer, easy peasy lemon squeezy. Gas G has 10 electrons. Gas H has 8 more electrons than G. Both gases are monatomic, therefore they must be noble gases. Which gas about G and H is correct? Both gases are in the same group. Yes, they're both in group 8. Both gases are in the same period. No, because they're definitely in the same group. Both gases are very reactive. No, they're unreactive. And gas G has a higher atomic mass than gas H. No, the other way around. Gas H has a higher atomic mass because it has 8 more electrons, therefore it has 8 more protons. The electronic structures of helium, neon and argon are shown. Which row describes these gases? So helium, neon, argon. Are they reactive or unreactive? Well, we can rule out A straight away because they are unreactive. Are they monatomic or diatomic? They're always monatomic, so we can rule out B. And C. We're left with D. Let's just double check. Do they have a complete outer shell of electrons? Yes. So the answer is D. 25. Which statement about elements of the group 8 of the periodic table is correct? Do they all have a full outer shell of electrons? Yes. Do they all react with group 1 elements to form ionic compounds? No, they don't react at all. Are they all diatomic? No, they're monatomic. Are they all liquids at room temperatures? No, they're all gases. 26. Which statement about the properties of elements in group 1 and group 7 is correct? They've come to take me away. Bromine displaces iodine from an aqueous solution of potassium iodide. Yes, bromine is more reactive than the iodine, so you will end up with potassium bromide. Chlorine, bromine and iodine are diatomic gases at room temperature. No, bromine is a liquid and iodine is a solid. So it's not B. Lithium, sodium and potassium are soft non-metals. No, they are soft metals. Lithium, sodium, potassium have an increasing number of electrons in their outer shell. No, they all have 1. 27. The melting and boiling points of the elements of group 1 of the periodic table are shown. Which pair of elements are liquid at 800 degrees? So, if they need to be liquid, they must have reached their melting point. So, 800 degrees C, well, all of these have reached their melting point, but they must not have reached their boiling point yet. So that means we can rule out lithium. Lithium has not reached its boiling point. Sodium has already reached its boiling point. Potassium has not yet reached its boiling point. Rubidium has not yet reached its boiling point. Oh no, sorry. Sodium has... So, 27. The melting and boiling points of the elements of group 1 of the periodic table are shown. Which pair of elements are liquids at 800 degrees C? So, they must have reached their melting point in order to become liquid. So, all of these have reached their melting point at 800 degrees. So, which ones are already gases? Because we don't want them to be already gases, we want them to be a liquid. So let's rule out some elements here. So is this one a solid, liquid or gas? This one is a gas. This one's already a gas. This one is still a liquid. This one is still a liquid. Which pair of elements are liquid? 27. Oh, other way around. So 27. The melting and boiling points of the elements of the group 1 of the periodic table are shown. Which pair of elements are liquid at 800 degrees? This is a fantastic gift question because it's just interpreting the data. So, have they reached their melting point and become a liquid? Yes, all of these are already a liquid. They've passed their melting point because it's 800 degrees. So what we want is for them to have not reached their boiling point yet. So this one's definitely reached its boiling point. It's a gas, it's a gas, it's a gas, because we have gone past their boiling point. So the two that are still liquid haven't reached their boiling point yet, so we're talking lithium and sodium. The answer must be C. 28. Which statement about the elements of group 1 and group 7 is correct? Bromine reacts with potassium chloride to produce chlorine. No, the bromine is not strong enough to displace the potassium chloride. Iodine is a monatomic non-metal. No, it's diatomic. It hangs around as I2. Have no fear of ice-cold beer. Lithium has a higher melting point than potassium. Yes, it does, because melting points of the group 1s decrease as you go down the group. Sodium is more reactive with water than potassium. No, the other way around. So the answer must be C. Let's go to 29. Part of the periodic table is shown. Which row describes W, X, Y, and Z? So all the metals are X and Y are metals. So it's not A, it's not C, it's not D. It must be B. Let's double check. The non-metals are W and Z. Yes, they are. So question 30. The positions of elements W, X, Y, and Z in the periodic table are shown. Which elements form basic oxides? Well, we know at this side all of the metals form basic oxides. So you've got W and X for sure. We know that Z definitely is not. It's going to form acidic oxides because all the non-metals form acidic oxides and the halogens are all non-metals. So the only one that's got any dispute is Y. For that, we're going to go to our periodic table and we are going to just find out what that element is. So we're going to realize that this is boron, this is aluminium, this is gallium, this is zinc, and this must be copper. Well, we know that zinc is amphoteric, but we think that copper is a metal that is not an amphoteric oxide, so it's a basic oxide. So which elements form basic oxides? W, X, and Y. If it had been 1 over, if it had been zinc, it would have been amphoteric, but it's not. In this case, it's basic.